Okay, welcome back to another video, guys. So in this video, we will discuss based on paper 1 actual SPM 2024 Addmaths, question 13 all the way to question 15. Okay, now let's look at the questions together, all right? So diagram 10 shows point P, Q, and R on a Cartesian plane. A1, find PQ in terms of H. Now, if we want to find PQ, all right, so this is P, connect back to Q. So there are actually an easier way for you to do this. PQ, right, is actually, let us write it down. PQ is from P back to O and then plus O to Q. So P back to O, right, how do you get this actually? Now, from O to P, you must always remember, everything started off from origin towards the coordinate, right? You're going to get this vector, exactly the coordinate for H to H. But now, what information you need is going in the opposite direction, P to O. So if you need P to O, right, then you will most likely have to add a negative at the front, followed by 4H to H. OQ, as I said just now, everything started from origin towards the coordinate. You will follow exactly how it write it down here, 0, negative H. So what I want you to write down here, OQ is 0, negative H. So make sure, many students might make a mistake here because the negative, right, you don't only multiply towards the numerator or the upper part, but you also multiply to the bottom part. So in the end, right, you get negative 4H and negative 2H. Okay, plus 0 means plus 0 here, and plus minus H, which means you're going to get minus H at the bottom. So eventually, you will get negative 4H at the top, negative 2H, negative H, we get negative 3H, right? So negative 3H at the bottom. Now, whatever we represent here is column vector. So column vector, and you can actually turn this into the normal vector writing form, which is negative 4HI minus 3HJ. That is how you want to write it down as the answer. Of course, you want to make sure that your answer is in terms of H because that is the requirement in our question A1. And let's go to A2. A2 says, given that PQ is a unit vector, this is very important keyword, find the value of H. How do you actually find the value of H? Now, when they say unit vector, right, there is one thing you have to think of, and that is magnitude of unit vector is equal to 1. I need you to remember that. Whenever we talk about unit vector, right, the magnitude of unit vector equal to 1 must came out from your mind, okay? Because that is the key for you to find the value of H. By all means, right, we will perform the unit vector, or so-called the magnitude thing, for the calculation of H. So magnitude is done by square root of x squared plus y squared. Where is your x squared and y squared? Everything in front of your I is x, everything in front of your j is y. So x squared plus y squared equal to 1. So you want to write this down. Negative 4h squared plus negative 3h squared equal to 1. And then the rest is basic operation. So over here, let's continue. Throw the square root to the other side, you get 1 squared. Expand this equation, basically negative 4h squared, you get 16h squared plus 9h squared equal to 1. 1 square means 1, right? So over here, let's continue the next row. 16 plus 9, you get 25h squared equal to 1. And then your h squared should be 1 over 25. H is equal to plus minus square root 1 over 25. Now, if you square root 1 over 25, you'll get two possible answers. One is 1 over 5. The other one is negative 1 over 5. And you will have to pick the suitable one. Now, based on the diagram, right, it is much more suitable if you pick the positive answers, because if you put negative here, that means this is 2 times negative 1 over 5. And that will give you negative 2 over 5. But obviously, the y value shouldn't be negative because it's on top of the x-axis. So the only answer that is accepted in this case is 1 over 5 positive. Now make sure you write that as a conclusion whenever you finish off everything in A2. Okay, so that is A1 and A2. I hope you understand that. I think the key learning here is that how do we actually find the vector of PQ? By using P back to O and then O to Q. How do you actually write down what is OP and OQ? Next thing is, what is unit vector and what does it link to? Unit vector will link to something called magnitude of unit vector is equal to 1. You want to make sure that you are able to form an equation so that you are allowed to actually find any unknown within that equation. Okay, next up, B. Hence, by using vectors, show that the points P, Q, and R are collinear. Now, this is pretty simple because it applies the concept of parallel. When we talk about parallel in vector, right, we always think of one thing. Let's say I give you P, Q, R. Okay, collinear means, right, collinear means they are on the same line. Because in Malay, segaris is pretty easy to understand, but in English, right, the words is much more abstract, collinear. So collinear means all these 3 points, right, they are in the same line, all right, they are in the same line. And how do we show that all 3 points are on the same line? We talk about this concept, which is PQ is equal to lambda PR. It's just like a certain ratio that you want to prove it. So if I write PQ equal to, let's say, 1 over 4 of PR, right, you will immediately understand that your PQ per PR is 1 to 4. PQ is ratio 1. PR is the entire line with ratio 4. And you knew that from Q to R is ratio 3. So that will allow us to actually prove that all these 3 points is on the same line so that we are able to determine what are their ratios or basically their position within this straight line. So right now, right, we are dealing with PQ and R. And if you want to show proof, you want to go and determine what is your lambda. If you can actually make it up this lambda, then you will be able to prove that they are actually collinear. Okay, let me show you how this is done. Okay, so PQ equal to PR, lambda PR. You want to write this down. P, okay, your coordinate, right, is, let's see, PQ. Okay, PQ is negative 4 HI and then negative 3 HJ, right? So let us take it down there. Negative 4 times 1 over 5. Oh, this is the PQ. Let's write down negative 4 HI, negative 3 HJ equal to lambda PR. So do we have actually PR? P to R. Okay, it seems like we don't have PR, right? We don't have PR. But we can actually go and find what is PR. Now let me show you how we can find PR directly. Okay, right now I want to find PR, yeah? Now, if I want to get my PR right, first of all, I will have to have my coordinates clearly determined first. Now, for example, for P coordinate, right, is 4H and 2H, right? Since you already get your H, so this is P, 4 times 1 over 5, and then 2 times 1 over 5. So as a result, your coordinate for P is 4 over 5 and 2 over 5. Now, keep that in mind. You want to keep this as part of your solution. Now we got P. Then we have R as well. So to get your PR, right, you can do it this way. X2 minus X1, and this is Y2 minus Y1. You will get the actual PR vector using this method. So lambda X2 minus X1. Now, X2 and Y2, right, must be specifically the one at the back, which is the R letter. So R information must prioritize first. So I want you to write it down. This is negative 8, all right, negative 8, and then take away negative 4 over 5. Because you want to deduct the X1, which is P, and then Y2 minus Y1 means negative 31 over 5. You want to minus the so-called 2 over 5. And then I suppose your lambda at the back here, you're going to get as a result is negative 44 over 5. And this is negative 33 over 5. Okay, and then at the left-hand side, this one, you can also make it into column vector. So this is negative 4H, negative 3H. All right, and that will looks better. in overall of the calculation. Now we're going to continue from here. How do we actually get our lambda? All right. Now I want you to take this equal to lambda times everything at the top here. So negative 4h equal to lambda bracket negative 44 over 5. We have our first equation, and then the second equation is by comparing negative 3h equal to lambda bracket negative 33 over 5. So you want to make sure that you get your lambda here, okay? And of course, the h value we already predetermined earlier on. We just put it back. Negative 4 times 1 over 5 equal to lambda negative 44 over 5. This is negative 3 times 1 over 5 equal to lambda negative 33 over 5. Okay, so this is negative 4 over 5 equal to lambda negative 44 over 5. And over here, negative 3 over 5 equal to lambda negative 33 over 5. And just now I mentioned that you want to make sure that the lambda that you found in both of this equation, right, should be tally. Because if it doesn't tally, that means they are not collinear already. So if it's tally, right, if it's the same answer, then you're going to prove that they are collinear, which means PQR are on the same line. So what you want to do here is to bring this down. So negative 4 over 5 divided with negative 44 over 5. I suppose your lambda you will achieve at 1 over 11. Same goes to the right hand side. You want to throw this to the left. So negative 3 over 5 divided by negative 33 over 5. And you're going to get your lambda result is 1 over 11. So you have proven that that's PQR, right? It is actually PQ equal to so-called 1 over 11 of PR. That is how simple it is. So if you want me to dissect or interpret based on a visual, now PQ equal to 1 over 11 PR, right? That means PQ over PR is 1 over 11. You could actually imagine that the PQ, it's only stand for 1 out of 11. 1 out of 11. So the whole entire line PR here represent 11 in ratio, the proportion. So from Q to R all the way stand for 10 in ratio. And that is where we can actually determine their position in a straight line, as in whether Q is much more closer to P or closer to R. So that is the purpose of what we are doing it here. Okay, and so we have proven, and that will be 4 marks to actually show that those are collinear. Okay, now you may consider pause the video if you need it. That will be question 13. Thank you very much for staying by until we finish the first question of the video. We're going to continue with second question. And also make sure that take down those notes if you need it. If you learn something, do make sure to support the channel by clicking like the video and subscribe the channel. Thank you very much. Let's continue diagram. 11.1 shows the relation of 3 sets. Okay, so we have 3 sets here. They say state GFX. All right. Now, some student, right, might find it confusing if they have like some sort of triangle kind of diagram in function. So I would always recommend you to do it in a row. So when I say in a row, that means you want to write this down. X, arrow, and then x minus 2, and then arrow, x squared plus 1. Okay, and then over here, x minus 2 to x squared plus 1 is through function g, and then x to x minus 2 is through function f. So pretty simple. All right, you just look at this way, and then now they want GFX. What does GFX mean? GFX basically means they want the so-called composite function, but for us to get this composite function, we can actually get it straight away from the diagram, which is x squared plus 1. Okay, because GFX, right, we always look at this way. GFX, you will straight away get x squared plus 1. All right, this is how the composite diagram works. Next, B1, determine f inverse x, hence find gx. Okay, so since, right, we knew that fx, as you can see, fx is x minus 2. Okay, fx is x minus 2. So with this x minus 2, we want to convert it into the inverse format first. So to make it inverse, pretty simple, 3 steps. Okay, let's fx equal to y. So x minus 2 equal to y, x equal to y plus 2. And then I want you to rewrite this, f inverse x equal to, change the y into x. So x plus 2. All right, now you already have f inverse. how do you actually get your G? Okay, I'm going to give you another concept here. You must understand this. When a normal f and f inverse, they meet together, right? We can cancel them. So if you notice just now, we have gfx. Gf, if I replace the x with f inverse, the answer that I get will be gx. Okay, and if you're already writing down, you already write down in this form, that means you want to replace or substitute your f inverse into your gf function. So look at how I do this. X squared plus 1. So your x now changed to f inverse. So this is x plus 2 squared plus 1. That is how it works. Okay, and then as I mentioned just now, the concept is a normal function f and an inverse function f, right? It's like positive and negative, you made together, you get neutral. So cut off, you left gx here. Now you want to expand this equation. So this is x squared plus 4x plus 4. And then you want to plus 1. So eventually you get x squared plus 4x plus 5. And that will be your function gx. Okay, so that is how you do it. So that is B1. Let's look at B2 then. Okay, B2 says diagram 11.2 shows part of the graph of y equal to gx. They wanted to sketch the graph of G inverse on diagram 11.2. Now, G inverse, right? If you want to sketch it, there's one thing is important. This y equal to x line. Because whether it's inverse, whether it's a normal function, they all reflect at this line, y equal to x. And when I say reflect, right? If this is the starting point, 0p, then you want to sketch another one at p0. You want to sketch another one at p0. So p0 means we assume here is the p. And then we want to draw another line, which is somehow like a mirror effect. So your G inverse should look something like this. Okay, and then I need you to label this down, G inverse x. That is how you're going to sketch it. Always remember, G inverse and a normal function, they reflect at the line y equal to x. This is very important. Make sure you write it down in your notebook. Okay. So we are done with B1 and 2 already. Okay. We got 4 marks here and we got 1 mark here at the top. 5 marks as for now. We have another 3 marks to go, which is they want us to find F2, F3, and F4, and then eventually state 75, F75. Okay, now I'm going to show you how we can do this. Okay, so our fx is x minus 2. Now f2x basically means ffx. So what is ffx? Ffx means f, you put it back to f. So that will be x minus 2 and then minus 2. See, the x here must put in exactly one more f inside. So x minus 2 minus 2. So you're going to get as a result, this is x minus 4. Now f3x means f and then f2. So that will be f2 putting in into original f, and that will be bracket x minus 4, and then you minus 2 again, you get x minus 6. Let's go with f4. Okay, f4 means f3. So you want to put in f3 into f, and that will be bracket x minus 6 minus 2. So x minus 6 minus 2, you get x minus 8. Okay, now the problem is, how do we actually determine so-called f75? Okay, because f75 is way, way further from what we are doing here, right? We have f1, f2, f3, f4, but we certainly don't want to do up until f75. So the best way is to deduce a pattern of the function. So you have f and x. Okay, now based on the pattern, right, it is quite clear to us. For f1, you get x minus 2. When you have f2, right, you get x minus 4. When you do f3, right, you get x minus 6. When you do f4, right, you get minus 8. So there's a pattern here from 2 to 4, 4 to 6, and 6 to 8. Now, we can deduce a function here, x minus 2n. Okay, why do I say so? Because every time if I change this n into 1, my n will also change to 1. and I'm going to make sure that it gets back exactly the same function as what I did. Okay, if you see, I change the n to 2, right? Then I will get 2 as well. I mean, I will get x minus 4, which is the result that we did just now. So based on this pattern, if today you ask me what is f75, right? I can clearly tell you this is x minus 2 times 75. You get x minus 150. And that is how you want to solve this kind of question. Okay, so keep that in mind. If you can notice the pattern of it, make sure you try to deduce this one. And then from there, you can actually switch the n numbers here, and eventually you will be able to get the f75. Even though today, if they ask me f1000, I will still be able to answer the questions easily because I already verified my functions here, the n functions. Okay, so that is the end of question 14. I hope you get something out of it. That is another 3 marks over here. And do remember, in section B, paper 1, you only have to answer 2 questions out of 3. So if let's say you are dealing with question 13 and 14, then you are good to go. All right, you may proceed with paper 2. And let's say students who are picking question 15, which is Form 4 Chapter 2, here we are finally. Thank you for staying by until the question 15. Let's continue our discussion. So diagram 12 shows a square and a rectangle, given that the sum of the areas of the shape is more than 8 meters square. Using the table method, find the range of values of x. Okay. So it says sum of the areas of the shape is more than 8 meters square. And that means, right, I have to create an equation of the square and a rectangle. Make sure I add them both and write an equation more than 8 meters square. That's how it works. So this is x, this is also bx. That means x times x is x squared plus the length times width should be area, right? So 2x plus 10 times with x, and they say the sum of these two shape area is more than 8. So more than 8 means greater than 8, and that is how you start your question. Okay, let's continue from here. This is x squared plus expand this, you get 2x squared plus 10x. Make sure you want to make the 8 to the front here, minus 8, and then make it greater than 0. So that will be 3x squared plus 10x minus 8 greater than 0. Okay, you want to create a quadratic equation because it will be easier for you to find range of values of x from here. Okay, so next step is I need you to press your calculator. Key in a value is 3, b is 10, c is negative 8. You're going to use the factorization method to get the so-called roots first. So once you key in a, b, and c in your calculator, I suppose you're going to get 2x answer. The first x answer is 2 over 3. Second answer will be negative 4. So you want to reverse your answers and make sure you want to include the double bracket here. 3x minus 2. And this one will be x plus 4. Write it back greater than 0. Okay, write it back greater than 0. So with this in mind, how do you continue this with the table method? All right, let's say if I have space or not. Okay, let me bring this down. Oops, okay. So I'm going to start creating the table here. Now, table method means you have to do it this way. Let me draw a table. Okay, first you put down this bracket, this 2, 3x minus 2, and then x plus 4. And the other one is you want to combine them. 3x minus 2 times x plus 4. And then you want to break it into 3 columns here. So that will be first column, second column. Okay, make it into 3 column. So what you want to do with this 3 column is, I want you to write here x less than negative 4. Pick the smaller number. The smaller number, make sure you do less than sign. And then in the middle one, you want to do negative 4 less than x less than 2 over 3. The last column, you want to make it x greater than 2 over 3. Now, when I do this, right, it means I have to select whatever the value. So less than negative 4, let's say we choose equal to negative 5. So we want to take this negative 5, right, put it into the so-called bracket thing. So this will be 3 times negative 5 minus 2. Okay. So you're going to get an answer which is negative 17. And then negative 17 itself, right, is a negative answer, right? So this is for your own reference. And then you want to continue this with the second row, which is negative 4 and negative 5 plus 4. As a result, you get negative 1. So negative 1 is a negative answer. Now, this 2 here means the first answer, negative 17 times negative 1, you get 17 positive. 17 positive, you write down positive here. Okay, now we're going to pick again a number in between negative 4 and 2 over 3. Let's say we pick x equal to negative 1. Repeat the same process. 3 times negative 1 minus 2. Okay, we get negative 5 here. This is negative answer. And then this one will be negative 1 plus 4 equal to 3. We get a positive answer. Over here, negative 5 times 3, you get negative 15, which is a negative answer. Okay, next thing, x greater than 2 over 3. Let's just pick x equal to 2. So that will be 3 times 2 minus 2. You get 4 as a result. This is a positive answer. And then 2 plus 4. 2 plus 4, you get 6, positive answer. And that will be 4 times 6, which is 24. It's also a positive answer. So in the end, right, how do you determine or decide which one will be your range, right? That is the most important question. So here, I'm going to teach you how you want to decide. You want to base on this sign here. Now, if the sign is greater, all right, if the sign is greater, you're going to choose positive sign. And you want to only refer to your last row. The last row is the most important. Refer to positive sign if this is greater or greater than equal to. Okay, if it's smaller sign, then you want to look for the negative answers, the negative value column. But right now it's positive sign, right? So you want to pick this column and this column. Refer back to this two column. Where is the range that we have put down? Your answer will be x less than negative 4 or x greater than 2 over 3. And that is how you work table method. Okay, now the structure is the same though, even though next time they say use table method, right? It will always be this framework. You want to rearrange equation, factorize, key in calculator, get two roots, and then create a table, repeat the process that I did over here. Okay, and that will be, how many marks are there? 2 marks. Okay, another 6 marks here we go. So to do with another 6 mark here, let's do it with B1 first, okay? B1. So B1 here, it says a quadratic equation. I'm sorry, my neighbor's dog is still barking. I'm so sorry for the noise and disturb. Let's continue focus on the question. A quadratic equation is given by x squared plus 3x equal to negative 4/8 at 4p, such that p is a constant. Find the range of values of p if the equation has imaginary roots. Now, what is imaginary roots actually? Now, it actually refers to your roots actually doesn't exist. All right, your roots actually doesn't exist. And another thing to link to is b squared minus 4ac is less than 0. Now, this is the keywords that actually bring us to, because if you have this in mind when they talk about keywords imaginary roots, you should kind of wire your mind to b squared minus 4ac less than 0, because that is most probably the way to help you get range of values of p. Okay, now I'm going to show you how exactly we're going to solve this. B1. Okay, to get your range of values of p, right, write down the equation first. X squared plus 3x plus 4p equal to 0. Okay, I actually moved the negative 4p to the front already, yeah? So once I move that, right, I try to write down my b squared minus 4ac less than 0. So my a value, my b value, and c value must be clear. B is 3. 4 times 1 times c value, it's 4p, and then less than 0. Okay, and then from here, right, 3 squared is 9. 4 times 4 is 16p, less than 0. So move this to the right, 9 less than 16p, and then you want to get your p, right? So you throw this, 9 over 16 less than p. Now, usually we will write our p on our left-hand side. So you want to be careful here. P is actually greater than 9 over 16. I did not purposely change my sign. I write it here, and then my sign changed because initially, right, you see here, the tip of the sign is pointing towards 9/16. So if you switch your P on the left side, your sign here, the tip, must also pointing 9/16 because you don't want to change any meaning of the equation. All right, so that will be B1, the range of so-called P values. Okay, P is greater than 9/16. That is B1. Let's look at B2 then. It is given that the equation has roots alpha and beta, and form a quadratic equation with roots alpha minus beta plus 1 and beta minus alpha plus 1. Okay, cool. So B2. Okay, B2. Now let's start with the roots of alpha and beta first. So we're going to create SOR, sum of root. Sum of root is negative b over a, and POR is c over a. Okay, sum of root and product of root, we have negative b over a. So alpha plus beta is negative b over a means negative 3 because a is 1, right? So you get negative 3 here. Then the next thing is POR, alpha times beta, you get 4p over 1. So you still get 4p here. Okay, so that is alpha plus beta equal to negative 3. Alpha beta is 4p. Now they want us to form an equation with these roots. Okay, it looks very confusing, right? I mean, as in you look at the screen here, alpha minus beta plus 1 and beta minus alpha plus 1. But don't worry, okay? Let's look at this together. We're going to solve it. New SOR. Okay, alpha minus beta plus 1 plus the other roots is beta minus alpha plus 1. Okay, I hope I didn't actually take down the answer. Take down the question wrongly. Okay, with this in mind, we will expand the equation. All right, we can expand the equation. So if you expand this equation, what do you get as a result? You see alpha minus alpha, no more, right? Negative beta, you plus beta, no more. What do you left? 1 plus 1, you get 2. Okay, you get 2. So the new SOR is 2, which is pretty simple and straightforward. But for new POR, right? Okay, this one you're going to be careful. So alpha minus beta plus 1 times with beta minus alpha plus 1. Okay, let's do it step by step, okay? I want you to listen carefully because you want to get this right. So let's do it one by one. Alpha times beta, alpha beta. Alpha times negative alpha, you get negative alpha squared. Alpha times positive 1, you get alpha here. Okay, you get alpha here. Then the next is negative beta times beta, negative beta squared. Negative beta times negative alpha is positive alpha beta. Negative alpha times 1, negative beta. Okay, last one. 1 times beta, beta. And then 1 times negative alpha, negative alpha. 1 times 1, plus 1. Right, plus 1. Here we go. Let's continue. So we will left with negative alpha squared minus beta squared followed by 2 alpha beta because we have 2 here, and then followed by plus 1. All right, followed by plus 1. There are some of it will be removed. For example, negative beta and plus beta. Now this one will be removed, no more. And then we have also alpha and minus alpha. This one also removed, no more. So you see, we only left with negative alpha square minus beta square plus 2 alpha beta and plus 1. Now to continue from here, right, this one we speak on experience. So the next step you have to do is you want to actually turn this into a negative bracket, write it down alpha square plus beta square, okay, and then plus 2 alpha beta plus 1. And then the next step is you want to convert this into bracket alpha plus beta square minus 2 alpha beta, and then followed by everything at the back, the same thing. Okay. Now, if you don't believe me, right, I didn't change the meaning of the equation. The alpha square plus beta square is exactly came from here. Bracket alpha plus beta square minus 2 alpha beta. You try to expand this equation, I'm sure you're going to get back exactly this thing same. Okay. So I'm not going to waste time on expanding that again. Okay. I'm going to just directly substitute the value here. So negative bracket alpha plus beta, that will be this one, negative 3. So negative 3 square minus 2 alpha beta, it's 4p, I remember that. Close bracket, plus 2 times 4p, and then plus 1. So over here, right, you want to continue minus. Okay, negative 3 square, it's 9, minus 8p, and then this is plus 8p plus 1. So expand the bracket, negative 9 plus 8p plus 8p plus 1, you get 16p minus 8. All right, you get 16p minus 8 for your new POR. So you want to form an equation following the rule of x squared minus SORX plus POR equal to 0. So x squared minus, I remember that the SOR is 2, right? Okay, 2x plus 16p minus 8 equal to 0. So that would be x squared minus 2x plus 16p minus 8 equal to 0. And that is how you get your new equation with the roots of alpha minus beta plus 1 and beta minus alpha plus 1. And so that is the end of the discussion for the video today. I hope you all learned something. If you all learned something, please do consider subscribe, and this will help a lot in terms of the algorithm to push those videos out way further. Thank you very much for staying by. Again, my name is Jaden, or you can call me just Sir Jaden. Thank you very much. I will see you in another video. Let's cook Addmaths together. All right, see you in another video. Bye bye, guys.